Hey y'all, this is Mrs. Carnes. In this video we're going to continue our discussion on particle motion, and we're going to add in antiderivatives into the equation. So first of all, just a few more things we need to know. Remember, speed is the absolute value of velocity, and you looked at that in worksheet 3 when you filled it in for homework, hopefully. If the velocity and the acceleration have the same sign, then speed is increasing. And if velocity and acceleration are opposite in sign, then speed is decreasing. And you explored that in worksheet 3. So there's 3 ways to use an integral when you're talking about motion, and they can be easily confused, so these are some things to watch out for. So an integral of the velocity, notice there's no endpoints here, so this is an indefinite integral. Okay? It will give you an expression for position. So if you take the integral of velocity, it takes you back to position. So don't forget you will have a plus c because it's an indefinite integral. So this one has endpoints, so it's a definite integral. And so this time your answer will be a number. So there will be no plus c. So the number represents the change in your position over time. And that all goes back to the fundamental theorem. Since velocity is the derivative of position, the integral of velocity gives you position at time 2 minus position at time 1. It's also known as displacement. So change in position is known as displacement, how far away you end up from your starting point. So the answer can be positive or negative depending on your original starting point. If it lands to the right or the left of your starting point. Right is positive, left is negative. Okay? And so then if we add absolute value bars in around the velocity, we're basically doing the integral of speed. This is still a definite integral. And so the answer will be a number. And the number represents the total distance traveled. So regular velocity, integral of regular velocity gives us change in position. Integral of absolute value velocity gives us total distance. And this answer should always be positive. You cannot travel a negative distance.